Hi, this is question number 10 taken from October 2015, Advanced Level Maths HSC P3. The diagram shows the curve y is equal to x squared over 1 plus x cubed for 0 is greater or equal, x is greater or equal to 0, and its maximum point M. The shaded region R is enclosed by the curve, the x-axis, and the lines x is equal to 1 and x is equal to p. First part, find the exact value of the coordinate of M. For the second part, calculate the value of P for which the area of R is equal to 1. Give your answer correct to 3 significant figures. 6 marks for the second part and 4 marks for the first part, 10 marks. Beautiful question. Alright, so let's do it. Right, so here we go. We have the equation of the curve is given as y is equal to x squared divided by 1 plus x cubed. Now, roughly the graph looks like this. Okay, and here we are. This is one line here, another one here. That's the region R, and here is M. Okay, so this is 1 and this is P. Now, what I would like to draw your attention to the fact that M is the maximum point on this curve. And it has been stated anyway, this is the maximum point. Therefore, at this point here, what we have to realize is that dy by dx is going to be equal to 0. So we're going to differentiate the curve and equate it to 0 to be able to find the exact value of the x coordinate of M. Alright, so let's do this. Now, to differentiate something like this, as you can realize, this is going to be, we're going to call this u, we're going to call this v, and basically this is where we're going to apply quotient rule. So u is equal to x squared and v is equal to 1 plus x cubed. Differentiating that, you get du over dx is equal to 2x, dv over dx is equal to 3x squared. So we're going to say v du by dx minus u dv by dx upon v squared. v du by dx minus u dv by dx over v squared is going to give you dy by dx. So v du by dx, therefore dy by dx, v du by dx is 2x times 1 plus x cubed minus u dv by dx, which is x squared times 3x squared, divided by v squared, and v is 1 plus x cubed, and we have to square it. So we're looking at 2x plus 2x to the power of 4, expanding this, minus 3x to the power of 4, all divided by 1 plus x cubed to the square. This is going to be dy by dx. Now, 2x power 4 minus 3x power 4 is basically minus x power 4 divided by 1 plus x cubed to the square. We stated earlier on that this has to be equal to 0, therefore this is going to be 0. So what we have here is 2x minus x to the power 4 over 1 plus x cubed to the square is equal to 0. This goes on the other side, it's going to be multiplied by 0, it's going to cancel out anyway. So we're left with 2x minus x power 4 is equal to 0. Factorizing this, you're going to put x outside. You have 2 minus x cubed is equal to 0. The x goes there, it's going to be divided by 0 anyway. So we're going to be left with 2 minus x cubed is equal to 0. X cubed is equal to 2. Therefore, x is going to be the cube root of 2. And that's the x coordinate of the point M, and this is its exact form. We're not supposed to to give it in decimal places or significant figures. Anyway, so for the second part now, we have to calculate the value of P. We have to find the value of P. Now, given that the area, okay, so let me just put this here. Right, we need to calculate the value of P. So how are we going to do this for the second part? If the area of the region R is equal to 1, we are basically, how do we find area anyway? Area is found by integrating fx dx. Okay, so we're going to integrate what? We're going to integrate this curve, so x squared divided by 1 plus x cubed. If we integrate this, let's call this the area A. We're integrating x squared divided by 1 plus x cubed. What do we recognize? This is the form of integration of f dash x over fx dx, which is going to be equal to ln x plus k. We're not worried about k because we have the limits, okay, and the limits are x is equal to 1, x is equal to p, where p is greater than 1. Now, how can we make this exactly like this one? So, we're going to say the area is equal to, if you differentiate this, you're going to get 3x squared, but this is x squared, so we can make it 3x squared if we want, but except that we have to put 1/3. Alright, and then we put it as this. 1 plus x cubed dx. Now that looks nice, because the 3 goes out, it's exactly the same as it was before, and then this is in the form of this one. So we're going to say then, we can put the 1/3 outside, and then you integrate 3x squared divided by 1 plus x cubed dx. Integrating this, you're going to end up with ln 1 plus x cubed. Now, this area is equal to 1 as given in the question, and we have our limits, and the limits are p and 1. Okay, so how are we going to do this now? Right, just substituting p in here. This is x is equal to p, this is x equal to 1. So we're going to say then 1/3 ln 1 plus p to the cube, right, minus, because 1/3 is common on both sides. I'm putting 1/3 outside anyway, ln of 1 plus x cubed. X is 1. 1 to the cube is 1. 1 plus this one is 2. Is equal to the area 1. The 3 can go there, alright. So that's going to be then ln. When we have minus, what do we remember? For minus, we have to divide if it's logarithm. So 1 plus p to the cube divided by 2. And the 3 goes there, so 1 times 3. And if you take away the ln sign, you're going to end up with 1 plus p to the cube divided by 2 is equal to e to the power of 3, because 1 times 3 is 3, e to the power of 3. Why e? Because we have eliminated ln. So what is p? P is going to be 2 times this, so 2e to the cube. Send the 1 on the other side, becomes minus 1. So that's the value, but we've been asked to give this value to 3 significant figures. So this is quite easy, just use your calculator. So 2e to the cube, so that's 2 times e to the cube, this is e right to the cube. Okay, then you minus the 1, isn't it? It's going to give you, oh no, hang on, let's put it separately, so let's calculate this, funny, e to the cube, okay, times 2, right, and then you minus the 1, it's going to give you 39.1710 something, so p is equal to 39.171, and to 3 significant figures we're looking at 39.2. 3 SF. Here we are. 10 marks in your basket. I hope you enjoyed this video.